Welcome to the Masters of Engineering podcast, episode 28. Cool products, the people who develop them, and how they do it. My guest today, Leigh Christie. So many things we could talk to him about, from his professional work at MistyWest, community work at EatArt, an amazing background, and an amazing vision about future tech in product development. Leigh, welcome to the podcast.
Thank you so much, John. Thank you for having me on Masters of Engineering. It's a real honor. I've been using software that was created by you in one way or another for the better part of the last 25 years. So, needless to
Oh,
say, it's a real honor to be here. Thank you.
well, it's an honor to have you here because I've heard so much about you and things you've built. That you're the at MistyWest, you're co-founder and leader of the company. What's
Yeah.
your title exactly there?
It's funny. I sometimes make the joke, when people come by here for tours of the office that, I'm the guy who waters the plants. Truth be told, I've over the last 14 years, I've hired a lot of really smart engineers and a lot of really
Yeah.
talented, very motivated um, product developers and business folks and sales folks. And as a result, I'm in a very privileged position where pretty much everyone. I'm surrounded by a bunch of people that are very extremely hardworking. And for example, I'm not the CEO, so that an honor goes to a guy by the name of Taylor Cooper, and he's been with us for about a decade, and he's absolutely incredible CEO. Runs the company in his many capabilities um, and many skills and stuff that I don't have, or if I do have, he's better at it, and so it's really exciting to be here under his leadership. But I get one thing that's really cool though is that I get to try a lot of experiments here. I'm sort of see myself primarily as an inventor, and as someone who just eats, sleeps, and breathes research and development, and so that kind of frees me up to be very experimental and try out new. And and so in some ways I do have a special role here at the company as a leader, in some ways as sort of someone who's very passionate about trying new things.
What is MistyWest doing?
Yeah, no problem. MistyWest is an engineering design company based in Vancouver, British Columbia. We're focused on mining tech and smart infrastructure, those two industries. And then within those industries, our horizontals are low power wireless devices, edge AI, and novel sensors, and sometimes all three at the same time. That's our
Cool.
specialty, and so that's our bullseye, if you will. Now that said, we don't really turn down work that is like adjacent to that. So every once in a while, we'll get a project that isn't the perfect bullseye, but it just so happens that our skill set is highly applicable. And but maybe the most important thing I can point out here is that for the vast majority of projects we do, the intellectual property belongs to the client or the customer, not us. So they hire us to do
Mhm.
the engineering, but at the end of the day, we're not the ones manufacturing the device, or we're not the ones
Right.
who own the product. Ultimately, that goes to our customers, and so yeah, people hire us to
Yeah.
accelerate their timelines so that they can ultimately get to market faster and stay ahead of the competition.
And who are some of the clients that you can name? Some of your clients that you can name
Sure,
publicly?
I can name a few, absolutely. So our biggest
I
clients
thought you could.
historically, yeah, our biggest clients historically have been, you know, Google, Microsoft. We've done some work for Amazon, Intel. There's a research organization in the U.S. called SRI. They're the ones who invented Siri, and
Mhm.
they sold Siri to Apple.
Oh, oh,
Yeah.
cool.
Done some work for MIT. It's been a great relationship over the years. I'm an MIT alum myself.
Mhm.
And then we've had a bunch of really great startup companies as well. We have this one mining tech company called Ideon that make muon detectors, and so a novel sensor, like I said earlier,
Hmm.
um, involving highly complex electronics. But maybe what I forgot to mention is that we're very focused on three engineering disciplines in particular: mechanical engineering, electrical engineering, and firmware engineering. Those are sort of our three main
Firmware.
disciplines.
You named some pretty blue chip premium kind of customers. They're big companies. There are a lot of product development firms that on the surface level would do similar things, build products, and turn over the IP for the customer to manufacture. What is the key to competing and growing and succeeding as you have for how many years is it now with MistyWest?
It's a little bit confusing because we founded the company, my business partner and I, Josh Usher, back in 2004 while we were still finishing up our engineering physics degrees at
Yeah,
University of British
yeah.
Columbia. And we started
Wow.
as a skimboard skateboard company. As it turned
Okay.
out, there's really not a lot of money in that, but that does explain where the name came from, which is a very common question
Uh,
people ask us.
yeah,
Is
what does it mean?
yeah, so it was a skimboard skateboard company. It was MistyWest, and it was, we're on the West Coast, and I don't know if you've ever been to Vancouver before, but it's pretty misty here.
Okay.
And so it was sort of yeah, it was sort of like a board sports, you know, company name, and it just sort of stuck. We just kept the name as we turned into an engineering consultancy. So in around 2008 was when we started freelancing as engineering consultants, myself and Josh, and then we decided to incorporate the following year, and then I think the documentation actually went through in early 2010. So technically, we've been in business, incorporated as a business for 14 years.
If you had any advice to offer people who have started or are thinking of starting a kind of design consulting company, what's the
Yeah,
key to success for you?
yeah. If you want to start a design, if you really want to start a design consultancy, I think the first thing you have to ask yourself is, are you willing to put up with 10 to 15 years of pain and suffering? That's step that's step one. Um, it is like you said, it's a highly competitive market, but it's competitive in ways that are different than you might think. Our main competition are internal hires, and really what it comes down to is that most of these companies, they want to limit their headcount. They want to stay resilient. They want to keep things nimble and fast. And what they've learned is that it's if you're super reliant on consultancies all the time, you're gonna if that's your long-term strategy is to be reliant on consultancies, you know, um, that only really works if you're sort of one and done with your products. But if you have a product that you're going to keep maintaining and updating and building new products that are similar to it, usually you're better off hiring internally, right? And but the problem is that message, the of hiring internally, that drumbeat has been beaten for so long into the heads of entrepreneurs and the head into the heads of management teams, that what ended up happening is the pendulum swung a little too far. And so you started getting a whole bunch of startup companies that would raise, a few million bucks, and they'd hire up like 100 engineers, and then like a year
Mm,
later they'd have to lay off half their staff. And then when they go through
mhm.
those rounds of layoffs, those engineers would leave and go join the competition. And so that pattern has been a real problem in the last decade. And so what we're noticing ever since the pandemic is that more and more companies have realized that it's really important to keep their headcount under control. And so for a company of less than 20 people, typically what that means is you want approximately about half your engineering resources should be external. So
That's what you
uh,
recommend. Yeah, yeah,
that's what we
external.
recommend, at least when you're that size. And as you get bigger, the percentage decreases over time. So as you
Yeah.
head towards 100 employees, you probably want to be something closer to 20-25% external.
Now, let me turn to some of the cool things you built. Tell us about the Mondo Spider, and I'm dying to know. Tell us what it is, and tell us why you built it.
Mondo Spider, yeah, sure thing. Mondo Spider has been around for since 2005, so coming up on 20 years. And it was a hit on YouTube. We posted a video. It's an eight-legged walking machine that looks a bit like a spider. It's the size of a car. You sit in it, you drive around like a tank. So you go forward,
Yeah.
reverse, turn, turn. And it's been to Maker Faire a bunch of times. It's been to Google I/O. It's been to Russia. I went to Russia, about Bal Robotov in Russia. I built it with a guy named Jonathan Tippett, another guy, Charlie Brinson, um, and
So,
Ryan Johnson, Sam
so
Meyer.
this, so this an eight-legged walking robot that's big
Yeah,
enough that a human rides in it and drives
yeah.
it. So, why did you build this?
Well, we built it because we could.
Because you could, right?
So we built the first prototype for it as part of the Vancouver Junkyard Wars. And so for many, many years, there was this thing called the Vancouver Junkyard Wars. It was created by a bunch of engineers that came out of Ballard Power Systems, Zaber Technologies. Um, and some people from MistyWest, and also Grin Technologies here. Um, and these different groups would form these teams of engineers, and then the teams would mix and match engineers from different companies, and they would all go and compete against each other. You'd buy up all this junk, and then you'd go and spend a day or two building some, like a frisbee throwing machine or a pumpkin launcher, or
Okay.
yeah.
Okay.
And one year the competition was a walking machine. And so we actually lost the competition. We came second. The company, the group that won that year, they built like a shuffling machine, so it walked, but it was just kind of shuffling, and it was much easier
Hmm.
to do that. We went for broke. We built one that could take these big, huge steps, and of course,
Uh,
we built it out of bicycle parts and door hinges and wood and stuff, and it
uh,
completely fell apart. It just got destroyed itself during the
gosh.
competition. So,
Well, it's
but
part of learning too.
that's right. And we were so stoked on it. We were so like inspired by this competition, and we really felt strongly that we needed to build a follow up to that prototype. Actually, if you look for that prototype on YouTube, there's actually videos of it. But we yeah. So like a few months later, we decided we were going to build this thing, and actually the father of Charlie Brinson, his dad said, "Hey, I'll fund a few $1,000s towards building, towards." We were very naive. We had no idea how much it was going to cost, and we're like, "Okay, well, if
Hmm.
we built the junk version in 2 days, let's build the next version." And
Hmm.
so we had a few $1,000 from him, and then from there we actually got really lucky. The Burning Man organization, they saw that what we were doing, they found out about what we were doing, and we went and submitted an application for funding, and they fund art projects. Burning Man funds these massive art projects. I think they spend over $1 million every year on art at Burning Man. And so we applied for funding and we got it. And then from there we put in a bunch of our own money personally, and we managed to build this Mondo Spider, not out of junk, but out of pretty cheap scrap, pretty cheap steel, basically not scrap steel, but cheap
Okay.
steel. And then from there, we many years later, we got another grant to upgrade it to electric. So it used to be a gas powered motor, and then
Oh, really? Yeah.
yeah, yeah, and then we up. And so EAT the EAT Foundation stands for Energy Awareness Through Art.
So you got involved very early. You're one of the leaders or directors of the Eat Art. Can you tell us what is the Eat Art? EATART.
Sure,
And for those of you listening, it's EATART.org. How are you
sure.
involved and what is it about?
It stands for Energy Awareness Through Art, and the idea is
Energy
to
awareness through art.
yeah, energy awareness through art, and the idea is to promote solar battery powered electric vehicle electrification. We came up with this idea like 2004, 2005, 2006, and it was long before anyone really knew about Tesla, and it was long before the electric vehicle revolution had come into full swing. And so at that time it felt like it was a really urgent thing to help solve global warming. So from day one we just sort of acknowledged, like, look, like art is worth it. That was sort of the main thing. It was like
Mhm.
we believe that humans could reduce CO2 emissions by substantially reducing our quality of life and reducing the population on Earth, and just not building art and just not doing things that create CO2. We could do that, but I think the more important message was, hey, look, we have technology now that means we don't have to burn fossil fuels. And that message we wanted to send that message to young people that there was this is getting a little bit philosophical here, but it really sort of felt like there was this existential crisis where children were being indoctrinated to think that the world is going to end. And it was really depressing for a lot of kids, especially young kids, especially teenagers, and that they were just being fed these really negative messages, about how humans were like locusts plaguing the earth, like a cancer that needed to be irradiated. And I just found that really depressing, and I found that to be really uninspiring for children, and for the youth. But the message of energy awareness through art was uplifting. It was like, oh my gosh, we can build electric cars, we can build solar panels, we can make artwork that is powered by the sun. Like, that was a really uplifting message that helped, I think, change the narrative away from humans bad towards humans, eh, humans could be pretty good. right? That's
Empowered, yeah.
yeah, and humans could be empowered, exactly. And so I think that that was, that was really kind of what motivated us as a nonprofit, as a charity. And Eat Art still exists to this day. It's still running. We got a new space here in Vancouver.
What
Uh,
age are the student participants?
so for safety reasons, we can't really have like young kids in the lab
Yeah.
itself because there's big, huge machines in there and like
Yeah,
welding
with the
and sparks.
projects you built.
Yeah,
Yeah.
yeah, yeah. You don't want kids
Yeah.
getting crushed by giant spiders. You'd be looking at like grade 12 and up, basically. Yeah.
Yeah. So teenagers, young adults, older children, young adults, grade 12, you said, and up. So
Yeah, I would
university.
yeah, a
Yeah.
lot I would say most are in university.
Okay. So it's a
Yeah,
university level program, but it's still you're reaching hundreds of young people directly. And then I
yeah,
assume the projects inspire probably thousands, tens of thousands, hundreds of thousands of people who hear about the projects, who see it. Just like the Mondo Spider must have
yeah,
inspired how many people were inspired by that to
millions,
go into engineering,
millions.
or to think differently in their life. Because, like you say, when you do things just because, it sort of stops people in their tracks. I know when I saw the project, I'm like, why would anyone build that? Well, it stops you, makes you think. You don't just go
Yeah,
by it. What projects are you working on now, whether Eat Art or otherwise, that you can talk about? Like, what's going to be the next thing that raises eyebrows that you're building, if you can
for
say?
sure. Yeah, well, first of all, maybe I'll mention just a few of the projects that we've done somewhat recent or more recent than
Okay.
the Mondo Spider. So there was Daisy, the solar powered tricycle, predates the
Mhm.
Mondo Spider. So that's a 7,000 pound tricycle that's 2 stories high that has giant solar panels on the back, and it's been to Burning Man like 10 times. So that project was built by Bob Schneevis in California, and then it was purchased by Rob Cunningham, who co-founded Eat Art with me. And so the way Eat Art kind of was born was Daisy, the solar powered tricycle, and the Mondo Spider needed a home, and so that Eat Art became their home. And then the next big project that came out of the program was Titanoboa. It's a 60-foot long electromechanical snake built by Charlie Brinson.
60-foot
Yeah,
long, 60 feet long, 20
yeah,
meters
it's huge.
long electromechanical
Yeah,
snake. And I know, Lee, you've shown me a video of this previously,
yeah,
but like that is like, again, wow, why
yeah.
build that? And is it inspiring people as you'd hoped?
Oh yeah, absolutely. So the diameter of that snake is about yay big. It's several feet. Yeah, it's
How many
absurdly big.
segments? How many segments of
Yeah,
articulation?
I think there's 5 segments per
Okay.
module, and I think that there's a total of 6 modules, I think. Yeah, so there's
So, and
30, like
once it's
20, 30 segments or something like
yeah.
that.
So the snake just kind of runs around and moves or does other things?
It slithers around. Yeah, it slithers and it can like
Slithers
lift its head
around.
up and it can open its mouth and stuff. And you can ride it. You can like sit on it and like ride it around. And then there's this other project that is probably even more insane. And that's Prosthesis, the four-legged walking machine. It's the world's first mech. And
What do you mean mech?
like a mech is like a thing that like a human straps into, like Gundam or
Oh,
yeah. So or like robot mech warriors or whatever it's called. Yeah, you strap in and your arms control. So this particular mech, your arms control the outer legs and your legs control the inner legs, and it walks a bit like a gorilla. Um, and so yeah, it's kind of hard to describe, but it's the world's first mech. If you just type in the world's first mech, it'll be the first thing that pops up.
okay.
This is the world's
Okay.
first real mech, and that is to say that the human body controls the limbs of this machine as it walks around.
Sort of like, if I may, the things you see in the Avatar movie.
That's the one. He straps himself into that big machine.
Yeah.
That's a
Yeah.
mech. Yeah,
The Colonel. Yeah.
Colonel.
And
Yeah,
so
yeah,
when the Colonel straps into that machine, that's the kind of machine you're talking about.
yeah,
And this is on the website, right? For Eat Art, right?
yeah. It's all on the Eat
If
Art
people are
website. Yeah,
interested, go to the Eat Art website. So you're
yeah,
building,
and,
this
and,
is a
and
current project
yeah, just to be
that
clear,
you're doing.
these projects have millions and have been seen by millions of people around the world. So
Amazing.
that mech project, that like prosthesis project in particular by Jonathan Tippett and his team, that one I think has the most views out of anything that eDart's ever made, even more than the Mondo Spider. And it's it's gone all over the world. It's in very high demand. People all over the world want a piece of the action because Jonathan Tippett is the world's first mech pilot, and that
Mm.
project is the world's first mech, and he's building more of them too. So he has a whole business that he runs. So even though eDart is a nonprofit or a charity,
Yeah.
which is helping like think of it as almost like an incubator. We get these people that come through and they build these projects, but the purpose isn't for them to be like charities. The purpose is for them to be building that as businesses, right? And so to enable them to be successful artists and to be successful creators and inventors is a big part of the why we do it in the first place.
Do you find that you, in the act of doing these projects, do you discover and expand the envelope of technologies that you use?
Absolutely, 100%. I
Yeah.
mean, I think that, I think the last 2 projects had multiple patents. It remains to be seen if these patents are gonna be valuable, right? Because, like, they're being used for what are essentially art projects. And so, but the question is how much of it is gonna translate over to industry? And it's not really clear what the answer to that is yet, but I think if history repeats, we'll see a lot of, intellectual property coming available and being useful in industry. In particular for, like, skeletal, like most of the things we create tend to be like skeletal type structures.
Mhm.
So there's a super, super lightweight. They're usually battery powered, usually solar powered, and they have to be super lightweight, right? And so a
Mhm.
lot of the techniques that we use actually were borrowed from like racing industries, like custom racing. So not
Hmm.
just like mountain bike racing, but also like vehicle racing and things like this. So um, and
Okay.
yeah, so I think there's a lot of IP there that could prove valuable, but time will tell. What we really need, like as a prerequisite for all these different machines to be really successful commercially, is that the battery packs have to become much more power dense. So you need,
Oh, great.
yeah,
Great segue to another topic. I wanted to ask you about your views on a number of future topics, and we'll see how many we have time for. And let's
sure,
let's go right to battery technology. It's crucial for
yeah,
so many things, whether it's
totally.
big systems, small systems. What advancements, what trends should we be keeping an eye on as fellow product developers that you're excited about in batteries? Let's start there.
Like MistyWest has done like a ton of battery work over the years, so that's kind of how we got started. Yeah, it's what I do for a living, right? It's how we started MistyWest is like back in 2010, 2011. Um, Almost all of our contracts were like working on like an electric Mazda Miata, a Porsche Boxster. We converted to electric.
When you say
And
you converted these, was it one-offs, like some enthusiast said,
yeah,
"Hey, can you make my Boxster electric?" Okay.
yeah, they
Uh,
weren't supposed to be.
uh,
Just to be clear, they weren't supposed to be one-offs. They were supposed to be businesses.
okay,
And
that's what I was wondering. What you
yeah,
so people came to you and said, "We wanna make a business." And by the
yeah,
way, now there are some really cool businesses out there to
yeah,
electrify cars, another story. We have some great Onshape customers doing
yeah.
that. But back to your story, so you did these electrification of vehicles. I didn't realize that was part of
Yeah,
MistyWest
that's
too.
not
All
what,
right.
and to be clear, that's not what we do, right? So
Yeah, not what you
we
do.
started out winning these electric vehicle contracts, and
Mhm.
we thought that. So if you look at our like the legal name of our company, it's like Misty West Energy and Transport Limited. That's like the full name of
Oh,
our company.
okay.
Yeah, but in truth, like we're very focused on mining tech, and we're focused on
Okay.
smart infrastructure. That's what we do, and most of the devices we work on are smaller than are smaller than a toaster. Um,
So
but
people who are out there designing products, if you're a product developer and you build things with batteries, you're familiar with today's batteries, and I'm a little familiar.
yeah,
I just did a project with lithium batteries, upgrading a motor home that I own.
nice,
It's really fun.
nice. Yeah.
Use some Lithionics
Oh, cool.
batteries, if you know
Nice.
them,
Yeah,
and
yeah.
to me, a very well engineered battery. But these are what's available today, and I want to ask you, what's coming in the future? What
Sure.
should we be
Yeah.
excited about in batteries? Is it just going to be the same batteries
Yeah.
like 5 years from now? Like the Lithionics battery I bought, it's been around for a few years, great battery, or
Yeah.
is there going to be what's new and exciting that we should know about?
Yeah, so that's kind of what I was leading up to is that with Misty West in particular, like even though that's not our core expertise, we do continue to get lots of battery companies and companies that use battery packs
Yeah.
coming to us to work on the electronics. So we're still doing all
Okay.
sorts of custom sensors for batteries, low power
Oh
wireless
yeah.
for batteries. Yeah, so that's kind of how we keep one foot in that industry. I started out in energy technologies originally. This is even before Misty West. I worked on fuel cells. And I want
Mm,
to point out that like fuel
mhm.
cells, they do have a future. There are certain applications for which they're
Good.
better. But one thing that's really crystal clear is that when it comes to passenger electric vehicles, it's no contest. The lithium ion
Hmm.
battery has won, and that's not going to change for a long time. And people say, well, maybe a new chemistry will come out. What people don't realize is that there's dozens, if not hundreds, of lithium ion chemistries, right? So it's lithium ion is a category of chemistries, if you will. You have different cathodes, different anodes, different electrolytes, and the pace at which they're getting better, both gravimetrically and volumetrically, ranges from sort of 5 to 8% per year. And people go, well, that doesn't make any sense because my cell phone battery just dies the same as fast as it did 5, 10 years ago. So for most people, they sort of see lithium-ion batteries as having not improved. And the reason why that's the case is because your phone just keeps getting better and better. Your phone is using more and more power all the time, even as that battery pack gets bigger. And in
I
fact,
see.
in some cases, they've actually shrunk the size of the battery. So you don't really see the benefits. The other thing is too is the calendar life has gotten better. So the lithium-ion battery used to have a terrible calendar life. This would explain why so many of our cell phones from many years ago don't work anymore, because the battery, or laptops and things
Uh-huh.
like this, the battery goes to shit.
Yeah.
But as it turns out, calendar life is massively improved. Cycle life is massively improved. And so the chemistries you want to be kind of keeping an eye on. Yeah,
Lithium batteries, what you're saying is they're improving every year. If I distill this down, the way like CPU chips improved every year,
yeah, but
in a
at a
sense,
slower
like
pace.
gets
At a s-
gets faster, slower pace, 5 to
yeah,
8% better in all dimensions. You
yeah,
point out, and like CPU chips in a way, you point out with the power in your cell phone, the more power you have, the more you use. That's the
yeah.
same with CAD, by the way. I was just in a discussion earlier. Whenever we make our CAD systems faster, you product developers run it to the limit again by making a more complex design. And we never
Yeah,
can solve, we're always
yeah,
feeding the monster. But so
yeah.
continuous incremental improvements in
That's
lithium.
right.
That's interesting because I
That's
didn't
right.
know that was going
That's
on.
that's
What
a bankable trend. Yeah, for
and
investors and
what so
inventors.
that's the exciting trend is stay with the
Yeah,
lithium batteries. But so when I go 5 years from now to get my Lithionics battery or
yeah,
something, it'll just be better.
yep,
And it's a family
probably.
of chemistries. Okay, let me go to AI. You just spoke, was it this year at CES
Uh-huh.
about AI?
I did. Yeah,
Cool that you were doing that.
yeah.
What were you talking about there? Otherwise, what should we be thinking about for AI? It's a hot topic. What should our audience, physical product developers, what should I be thinking about as a developer of CAD and PDM
Yeah,
with AI? By the
for
way, we
sure.
are thinking about a lot. So
Yeah,
I
yeah, yeah.
want your
I
opinion.
think, like, first of all, I should point out that our area of expertise in AI is specific to the edge. So here at MistyWest,
Mhm.
we have a SOM called Misty SOM. It can do two tops, 2 watts, so one tops per watt, and we're looking at building a new
SOM,
generation.
SOM,
Yeah,
SOM. Will you
system on module. Yeah, so it's very
system on
similar.
module? I just
So
want
most
everyone to know. Yeah.
No problem. Yeah, most people are going to be
Yeah.
familiar with single board computers like the Raspberry Pi,
Uh-huh.
right? That's a single board computer. A SOM
Mhm.
is like there's actually a thing called Compute Module 4. It's a compute module made by Raspberry Pi, right? And
Yeah.
what it does is they take the compute and they separate it from the carrier board. So you can actually plug this little tiny little credit card sized thing into a carrier board, and now you can change your carrier board and you don't have to change the SOM. Gives you some modularity.
You see.
Yeah, so we make one of those. The chipset is made by Renesas. They're a partner of ours. It's called the RZ-V2L, and it has a neural processing unit on board, so it can do it
Cool.
can do AI. I mean, not really AI. Let's call it machine learning. It can do machine learning on the edge, and where the industry is headed, very obviously, is the efficiency that these neural processing units can do. Dot products, so matrix multiplication and matrix addition, is
Mhm.
improving at an absurd pace, like faster than
Mhm.
anything I've ever seen in my 20 some odd year career as an engineer. The engineering that goes into these neural processing units is getting really sophisticated. They're improving very dramatically. So the next generation chip, I believe, is going to be able to do 20 tops at a similar power, maybe a little bit more power than 2 watts, but similar power. And what that means is that you can have these edge devices that are battery powered, solar powered, right? That are going out
Mhm.
there in the wild. You put them in literally in the wilderness, or you put them on a remote highway, or measuring erosion on a bank, or measuring for threats or security concerns, or measuring wildlife or invasive species. There's so many different applications where the intelligence is actually embedded into the device itself at the edge. That is to say, not in the cloud. And so
Okay.
that's what we specialize in, right? Is the hardware and the firmware, the embedded Linux software. as well as the cloud IoT layer that enables that AI to happen. That's what we're experts at. And we partnered with
So,
a
okay.
company called Edge Impulse. Edge Impulse actually does, like, they build the software to help you train your machine learning models on the edge as well. And so,
Okay, so a trend for our product developer audience out there is
yeah,
putting machine learning, AI,
yep,
in edge computing, low power devices into products that our audience is going to be building. Great
that's right.
trend to identify, really interesting. Think about that. I know you're a believer in cloud for the future of CAD and PDM and other product design tools. And a little self-serving to me because Onshape, we think we're the only truly cloud native system out there. But what is your view on what cloud will mean to the world of product development tools?
For sure. I should start out by saying that I've been an Onshape user. I think I first started using it in 2017. Just myself personally, right?
Mhm.
And so the first time I tried it, I was just, and I found out it was you, right, that created it. And I was like, that sold me on it. I was like, okay,
Well,
I gotta go, I gotta go try
okay.
this software out. Yeah.
Thank you.
It-
That's kind
y-
of you. Yeah.
yeah, yeah,
Yeah.
and to be clear, I do use it personally, and I very much I'm a cloud first kind of guy. Like, I'm all my
Mhm.
computers are just, like, I don't get attached to any of my computers because really it's just the
Yeah.
all my softwares run on the cloud at this point. And
Yeah.
so at Misty West, and myself personally, we're absolutely dedicated to the cloud. And um and so I would also say that, the other thing that we have going for us is that um we're also very, very focused on AI and the cloud together. And it's my belief that the
Mhm.
combination of artificial intelligence, spatial computing, and CAD, I
Mhm.
think, seems very likely, are all going to come together to form this sort of trifecta of productivity for CAD use. And it really does seem to me that cloud is the key to it all. That seems very likely. And then you look at not just Onshape, but you look at your competitors as well. It's very obvious that everyone is trying to head in that direction, and it does seem a little bit like you guys have a bit of a head start there.
Well, we think so. I mean, we think that, being fully cloud native provides benefits, but I'm not here to talk about,
All good,
Onshape being
all
better.
good. Yeah.
Well, last question here, because what would you want us to do with AI in the world of CAD and PDM tools? You said one thing, which is get it integrated with spatial computing. By the way,
Mm,
Onshape has released our Onshape Vision app for Apple
mm,
Vision Pro. Super
nice,
excited about
nice.
that.
That
What
is
do you want
exciting.
us to do with AI? Let's say, so we've got some degree of CAD on Vision Pro. It's live CAD data, not a viewer of files or something. What do you want us to do with AI for you? If we could, what's your
Mm.
vision for what we will do with AI for you in the future?
Well, the biggest one by far, I've had this sort of vision of, like, being in a headset, and I've used this program called Tilt Brush quite a bit. I've used other, like, quasi CAD applications in 3D, and none of the ones I've tried have ever really been able to be super compatible with a feature tree. And I was always thinking, how
Mhm.
valuable would it be to be able to sketch something freehand and then say to the AI, "Hey, now turn this into a solid object with a feature tree," where it actually, like, because I know that you can do that with step files, right? You get a step file, you can kind of recreate a feature tree
Mhm.
from a step file, somewhat
Mhm.
semi-automatically. But I think AI is probably good enough now. I mean, it would take a lot of work, but it seems like the kind of thing that AI should be able to do is, like, I'll sketch it up, and then, like, the AI recreates it as a solid or a surface, and then recreates that feature tree for me. I think that would be a tremendously
Great.
valuable tool. And then another really valuable tool, I think, would also be just like renderings. So, like, if you're ready to render something, the AI should be able to figure it out for you. You should be able to say, "Hey, render this for me in this lighting condition." Oh, and then the AI says, almost like a chat bot, says, "Oh, well, what angles would you like, or how many different views would you like, or
Yeah.
what resolution would
Yeah.
you like?" You say, answer the questions,
Yeah.
and poof, you get this amazing rendering.
Well, those are both great visions. I'll just tell you on the second one with the AI for rendering, I
Yeah.
think that's very doable technically today. And
Mm,
we've actually shown some cool prototypes at some of our events of things like that. And then the second one, love the vision. And you've given us something to work toward. I love it. And I hope
mm.
someday we'll come back to you and show that we're doing that. And so I just want to say a huge thank you, Leigh Christie of MistyWest. and Eat Art Foundation. Thank you
Yeah.
so much for joining us today. On behalf of myself and all of our listeners, really appreciate the time. So thanks for being here. I want to thank you also for inspiring us all with the creations you've made.
Thank
One
you.
only needs
Yeah.
to see from a distance, yeah, and inspiring, hopefully, the next generation of engineers, or many generations that have already come along in the next two. And
Awesome.
I'll thank so thank you for that. I'll thank our listeners for tuning in. Again, if you want to learn more about Leigh, can they reach out to you on LinkedIn?
Oh, absolutely. Yeah, certainly.
Okay.
Yeah.
Yeah, you're on LinkedIn. And then also MistyWest.com, MistyWest.com, and EatArt.org to learn more about Leigh and Eat Art and MistyWest.
Mhm.
And that's it for today. See
Thank
you
you.
all next time.
Thank you
Yeah,
so
see
much,
you
Sean. I
out
really,
on
really appreciate you having me on. This has been wonderful.
wow.
Thank you so much. And you're an inspiration. And what can I say? Thank you so much for having me on.
Oh, it's nice of you to say that.